The diagram shows two cars approaching an intersection with some velocity. They collide at intersection as shown, and they become entangled with one another, sticking together after impact. A close investigation of the scene reveals that after they entangle together, they both move in a direction 30 degrees above horizontal. So the question is, what should initial velocity of car be for the given situation? So let's write the law of conservation of momentum for the system, which says total initial momentum net MVI equals to net final momentum. And recall that this is a vector equation. I can apply this equation to the given situation and write mass of A times velocity, initial velocity of A, that plus mass of B, initial velocity of B, and this is a vector equation, equals to mass of A times velocity of A after impact, which I'll call VF. But since they stick together and move as one object, B has the same velocity, therefore its momentum is mb VF as well. So this is a vector equation. I can break it up and write the two components in horizontal and vertical direction. In horizontal direction, if I choose right as positive, I have MA VIA in x direction plus MB V initial velocity of B in x direction, which we know is 0, equals to MA plus MB. If I factor out the common velocity VF, its component in horizontal direction is VF cosine of 30. So I can solve this equation for the only unknown it has, which is VF. So let's plug in the given values. 1000 kilograms times initial velocity of car A is 25 kilometer per hour plus 0 equals to 1000 and 1500, add up to 25 kilograms times VF cosine of 30. Observe that kilogram cancels both sides. Then I could have converted kilometers per hour to meters per second, but if I'm interested in velocities in units of kilometers per hour, I can leave it as it is. And then if I take a calculator and solve for VF, I get a numerical value which is actually 25,000 divided by 2500 cosine of 30, or 10 over cosine 30. So this gives me a final velocity of 11.55 kilometer per hour. This is the final velocity of both cars. Now I can go to the second component of the momentum equation and write MA initial velocity of A in y direction, which we know is 0, plus MB initial velocity of car B in y direction, which is its velocity as it was driving, equal to total mass is 2500 and y component of final velocity is VF sine of 30. So if I plug in the numerical values, MB has a mass of 1500 kilograms, VIB is to be determined. Then I have 2500 times final velocity of 11.55 kilometers per hour times sine of 30, which is 1/2. Observe that kilograms cancel from both sides, therefore V initial B is simply 2500 times 11.55 times 0.5, the whole thing divided by 1500, and this gives a numerical value of initial velocity of car B as 9.622 kilometers per hour.